Today we present air conditioning with refrigerant gas R32. On the screen we have a graph, which will make it very clear to us, the superiority of the r32 over the r410a. We are going to make the comparison for two air conditioning compressors with the same displacement. Let's see how an air conditioning system needs 28% less magic flow of refrigerant with r32. This means that less gas is required. Now we can see how with r32 a greater cooling capacity can be achieved, which we can see with the enthalpy differential. Let's observe a bad point of r32, and it is its discharge temperature at the compressor outlet, which is much higher than that of r410a. Although this can be solved with the injection of cold refrigerant in the form of vapor and taking into account the viscosity of the oil that you must use the compressor with r32. Now in this table we can see a comparison of each parameter for various compressors used in air conditioning with both r410a and r32. The r410a that had been used regularly in air conditioning has begun to stop being manufactured once its use ban was announced from the year 2025, where in many regions the use of split air conditioning equipment containing less than 3 kilos of refrigerant with a global warming potential of 750 or higher, such as r410a. That is why as of 2015, the use of r32 in air conditioning equipment is common, and more manufacturers are including it in their new equipment. The traditional r410a gas is made up of 50% r32 gas and another 50% r125, so we have already been using refrigerant gas 32. The r32 presents multiple advantages over its predecessor, the r410. Although more flammable. Now let's study in detail the characteristics of the r32 refrigerant. 1. r32 refrigerant is a refrigerant classified as r210, slightly flammable, with a global warming of 675. 2. Refrigerant manufacturers have clearly stated that r32 refrigerant is not suitable for operating. 3. A system that was originally designed for r410a will not have taken into account the safety factors required when using an r210 refrigerant, and can create a significant safety hazard. 4. The system that works with r32 requires sensors, so that if a concentration of at least 25% of the lower flammability limit of r32 is detected, the mitigation system is activated. For example, valve closure is required, or other measures. 5. Detectors are required to have a constantly running self-test routine to ensure that they are functional and fail-safe. 6. R32 has better efficiency and around 10% more capacity than r410a, depending on the application and system design. 7. The charge amount of r32 refrigerant is about 20% less compared to r410a. 8. R32 is a relatively inexpensive, single-component refrigerant, which means it is easier to recycle. 9. Due to the high discharge temperatures of R32, the operating range of R32 chillers is more limited. 10. For operation in ambient temperature conditions, greater than 45 degrees Celsius, R452b or R454b are better options than R32. 11. Manufacturers have selected R32 for their scroll compressor chillers because of its lower impact on the environment. 12. Although many prefer r450 and 4b as a direct replacement for r410a in new equipment, r32 has the advantages of being a single-component gas, has no slip, and has price and availability advantages over its rivals. 13. R32 refrigerant is easier to handle and recover than other alternatives such as r454b or r452b. 14. In addition, since R32 has no slip, it is not necessary to vacuum the system before each charge, due to partial leakage. 15. The R32 is likely to remain cheaper than its competitors. 16. Apart from this, the fact that there is no patent on R32 guarantees access and availability through many refrigerant suppliers. Before we finish, we must answer two typical questions. Question 1. Is R32 refrigerant easy to ignite? R32 refrigerant is actually difficult to ignite and requires certain conditions to be met. 2. There would have to be a significant coolant leak. B. The leakage should be sufficient to reach the lower flammable limit concentration. C. Would there have to be an open flame or high-energy ignition source, where the concentration is sufficient to ignite R32? Question 2. Does the R32 ignite from static sparks? Not really, as R32 must be exposed to an open flame or high-energy source to ignite. We are seeing the absolute working pressures of the R32 refrigerant depending on the saturation temperature in the table shown on the screen. As we can see, the working pressures of the R32 refrigerant are very similar to that of r410a. For example, for a temperature of 6 degrees Celsius in the evaporator, typical of an air conditioner, we must have a pressure gauge of 8.81 bar, or 129 psi.
Instead, for a condensing temperature of 50 degrees Celsius, we must have 30.41 bar, or 447 psi of pressure. However, this is not all we need to know. There is something very important and that many omit. I'm talking about the discharge temperature, which has the refrigerant R32. Let us remember that the compressor discharge temperature is the most critical in the refrigeration cycle, as it is the highest temperature in the system, and must always be within the ranges that the equipment compressor and its lubricating oil admit. This value is higher than the condenser temperature because the refrigerant R32 is in a superheated vapor state. If a compressor works with higher discharge temperatures than it was designed for, it will quickly fail. Also remember that the viscosity of the oil refers to the resistance that this liquid has to flow or deform. If the temperature increases to inappropriate values, the viscosity decreases. This causes the oil to not stay at the points where it should be to achieve lubrication. Now let's look at the graph. Let's look at the discharge temperature of r410a and compare it with that of r32. We can see that the discharge temperature of R32 in this example exceeds that of r410a by 16 degrees Celsius, and this actually happens very often. From this we can conclude that if we update a piece of equipment that is working with r410a refrigerant, now adding r32 refrigerant, the compressor will have higher discharge temperatures, which will significantly shorten the useful life of the compressor. In the equipment specially designed for r32 refrigerant, this problem of the high discharge temperature is faced, either with cooling strategies or with different oil viscosities, so that the compressor does not have inconveniences. Let us remember that one of the causes for which some technicians decide to replace r410a with r32 is the lowest cost that the latter has. However, this is not justified if in the end the compressor of the equipment is going to be affected. In conclusion, neither for safety nor for the damage that will be caused to the equipment, we must replace the r410a refrigerant with r32 in systems that are already working. We look forward to your subscription to the channel. Thanks for joining us.